Hey everybody, Mr. Kolu back with a little more Kolu math. And today I'm going to be showing you a magic trick. I can take this fraction here, wave my magic wand, and turn it into a decimal. But that's not all, folks. I can wave my magic wand once more and turn it into a percent. Pretty impressive, huh? Yeah, I gotta level with you guys. Actually, I'm not doing any magic at all. If we go back and we slow up the tape, you can see, back from my perspective, that there's actually a lot of mathematics going on behind the scenes. So it's really not magic, even if some people think it is. It's not magic. It's just a numerical conversion. A numerical conversion is when you change the form, appearance, or units of a number without changing the size or the amount. You may have done this when comparing two different systems of measurement, like standard to metric. Okay, you need to make sure that you convert accurately so that the measurements still work when you're in a different country. Also, you can think about it in a linguistic kind of way. When you're speaking to someone in a different language, you need to translate, which is sort of like a conversion, so that they can understand you. Let's take a look at the sheet we're going to be working on today. Okay, it's a simple chart, 3 by 3. We're going to be converting from percent, decimal, and fraction to percent, decimal, and fraction. But maybe we're getting a bit ahead of ourselves. So, what are these things? Percent, decimal, fraction? Why do we talk so much about it? What's the point? Well, think about it this way. Say you live in Las Vegas, and your friend lives in New York City, and you want to go visit. So you ask for directions. How do I get there? His first response might be to give you directions. Take 70 east. If you get on I-70 and you head east, you're going to end up New York. Could also give you coordinates. Here he gives you the latitude and longitude for the Statue of Liberty. That'll also tell you how to get there. If you have a GPS, you can program that in. Then he might say something like it's across the river from Jersey City. He's giving you relative info so that you can find it if you know where Jersey City is. What I'm getting at is these are different ways of conveying the same information. In this case, how to find New York City. Which one works best depends on the situation. Here's something else to consider. Let's go back to the foreign language metaphor. For the most part, you can certainly say the same thing in different languages. But if you do not translate correctly, the translation doesn't function the way you'd expect it to. The same is true for numerical conversions. Different forms can have the same value, but they must be converted correctly to ensure that. What's the point? Percents, decimals, and fractions, they're different ways of saying the same thing, provided they have the same value. Okay, and that's what a good conversion is all about, getting that good value. So let's get started, and let's start with the character over there on the right, the fraction. And let's take a look at the definition. A fraction is one integer divided by another. And they often look like this. Sometimes you see a slash between them, sometimes they're on different levels and have a line between them. But A and B are always integers. And I think most people are pretty comfortable with the basics of fractions. So you see a problem like this, where you've got a bunch of apples and half of them are not ripe, and we want to know what fraction of apples are ripe. So first we count up the total number of apples, we get 8 total, and then we count the number of ripe apples, we get 4. That gives us a fraction of 4 over 8. Okay, 4 ripe apples out of 8 total. I think a lot of people are okay with that, but it gets a little hazy when we move on to this next concept. 4 over 8 is actually the same as other fractions. It has the same value as, say, 2 over 4, or even 10 over 20. All of these fractions have the same value, which equates to 0.5 as a decimal, or 50% as a percent. So all of these have the same value, but one of them is a bit more helpful when you connect it to our situation before with the 8 apples. So 4 over 8 tells us a little bit more. It's a little bit more relatable to what we're doing. Now, you may have a math teacher who tells you to reduce that, but I think that's kind of where people get lost, is they sort of lose that 4 over 8 is 2 over 4. They're just saying the same thing in a different way. One maybe makes a little more sense for the context. So all have the same value, but one is a bit more helpful, and in this case, that's 4 over 8, because it's actually telling us the actual numbers in the problem. Doesn't mean that 2 over 4 is incorrect or that 10 over 20 is, unless your teacher is telling you to reduce the fraction, okay, which would be 1/2, just in case you're worried. Yeah, but what about this guy? And what about this guy? Okay, we maybe got a little bit ahead of ourselves. Let's start by talking about the decimal. A decimal number is a number with a dot separating the whole number part from the fractional part. You've seen a bunch of these, but let's just take a look at them. Here's a decimal number with a decimal in the middle, and each of those numbers is in a different, what we call a decimal place. Okay, they have different place values. That means the 3 in the ones column is worth 3 individual things. 1, 2, 3. 3 objects. While a 2 in the tens column demonstrates 20. 2 tens is 20. And 1 100 is 100. Works the same way in the other direction, except now we're going into the fractional part. So instead of tens, we have tenths, hundredths, thousandths, 10,000ths, and 100,000ths. And using those place values is essentially how you read a decimal number. Okay, so now that we know what a fraction is and we kind of know what a decimal is, let's talk about converting them. To get started, let's take a look at the definition of fraction. Okay, fraction is one integer divided by another. What do you think the key word is in there? Yeah, I think we both spotted it. Divided. Yeah, so all I have to do is divide the top by the bottom to convert it? You got it. Let's take a look at this fraction, 3 over 5. Well, to calculate the decimal, all I have to do is divide. 3 divided by 5. I can do it in long division format. Or, if I want to cheat, I can use a calculator. Best part is, both will give me the same answer. So yeah, it's just that simple. If you want to convert a fraction into a decimal, all you have to do is divide. And in fact, take a look at the division key on the calculator over there. What does that look like? Yeah, it's a little fraction. To convert a fraction into a decimal, all you have to do is divide. Let's take a look at another one. Okay, here's 7 over 9. Well, let's do the long division over here. Okay, this is oh, wait. Huh. Well, this just looks like keep getting 7s, and I've kind of run out of space here. Let's see what the calculator has to say. Okay, 7 divided by 9 equals 0.777. Huh. Well, actually, guys, what we stumbled upon here is what we call a repeating decimal. Now, a repeating decimal is a decimal fractional part in which a figure or group of figures repeats forever. So before, in the last problem, we were coming up with 0.777777777777777. We can actually write that in shorthand. We can write it just like this. 0.7 with a line over the 7. And that line goes over the part of the decimal that repeats. So if we have something that repeats like 0.147147, we can write that as 0.147 with a line over the repeating part. And these repeating decimals may be a little more common than you think. They actually turn up quite a bit. So how can you tell if you've got a repeating decimal? If you use a pencil and paper, once you think you see a pattern, just verify it with 2 more digits. If the pattern continues like you expect it to, you probably got a pattern going there, and a repeating decimal. If you're using a calculator, if the decimal fills the screen and repeats, that's usually a pretty good indication. It's not proof, but it's a pretty good indication. And finally, you'll start to recognize repeating decimals by the fractions. Some famous fractions that are repeating decimals, 1 over 3, 2 over 3. 1 over 6, 2 over 6, 4 over 6, 5 over 6. 1 over 7, 2 over 7, 3 over 7. Go ahead, pop these in your calculator, and you'll see that they have repeating decimals. Repeating decimals are actually kind of common, believe it or not. Kind of blows people's mind. Actually, if anyone's ever interested, we could do a number theory Kolu math, and I could tell you guys some of the college level stuff about why this happens. Post in the comments if that sounds like fun. So what do we have to remember to convert a fraction to a decimal? Just divide the numerator by the denominator. Just that simple. What about the other way? Decimal to fraction. How do we do that? Well, let's take a look. Here's a decimal. And there's our decimal point. And let's put in those decimal places. Okay, interesting. Now you guys might have been thinking, hey, can I just swap those decimal places with fractions? And you're absolutely right. So something like 0/10ths becomes 0 over 10. Something like 100ths becomes 1 over 100. 5,000ths becomes 5 over 1,000. And 4 10,000ths becomes 4 over 10,000. And once I get rid of that decimal, I can just go ahead and add all these guys up. So let's do that. First, we need to find a common denominator. In this case, we'll use 10,000. Add those guys up. And that gives us a final value of 154 10,000ths. All right, you're probably thinking that was a lot of work. Let's see if we can find a shortcut. All right, considering what we know from the last answer, we do know that this is going to be 154 10,000ths, so maybe I can just use the last decimal place, make that into a fraction, and put it over to the numbers I have without the decimal point. That'll work, except I'm going to have to remember 10,000ths, remember all the places. There's actually a foolproof method that works really easily with decimals, converting them to fractions, and it works just like this. So here's your fraction. The first thing you want to do is write the number 1 under the decimal. Then, for every other number you have in the decimal, write a 0 underneath it. Draw a line to separate the two, remove the decimal point, and hey, look what I've got. A fraction, 154 out of 10,000. Not bad, huh? It works with other decimals too. 0.65908, doesn't matter how long it is. Just go ahead and put a 1 under the decimal, put a 0 under every other number, draw a line separating the two and get rid of the decimal, and hey, you've got a fraction. Perfectly converted. And you can even do it with decimals that have numbers in front, whole numbers. All you have to do is separate out the whole numbers, then follow the procedure like before. Put a 1 under the decimal, put a 0 under all the other digits, draw a line in between the two, and erase the decimal. So I've got 73 and 60,002 hundred-thousandths over there. So what do we have to remember when converting a decimal to a fraction? First, we separate the whole part from the decimal, write it to the side. We make a multiple of 10 denominator for the fractional part, and we place the remainder of the decimal over the denominator, remove the dot. Now we have a fraction. A little more complicated than the other way around, but once you try it a few times, you'll get used to it. So there's still one fellow we haven't spoken about yet, the percent. So let's talk about converting a decimal into a percent. And I guess first we should start by defining what a percent is. So a percent is the number of parts per hundred. This is a definition that people who understand percent throw around a lot and think is fully explanatory. But if you don't understand what a percent is, it's sort of meaningless. But let's talk about it, and maybe this definition will start making more sense, because we'll understand what a percent is. So if you're talking about something that's difficult to visualize, like say profits from 2013, and you want to compare them to 2014, we use the concept of percent to break them up into 100 pieces so that they can be more easily compared, and you get a kind of sense for it as you get older. Okay, why 100? Well, it turns out that the ancient Greeks actually used to break things up into 100 for simplicity. And they didn't even have a decimal system based off the number 10. So we don't really know why they picked 100. We just know that they did, and we still use it to this day. But it's okay because it actually works really well for things like populations, comparing percentages, things to do with money, business income, revenue, anything to do with science, things like correlation and likelihood. All these things are determined by percent most times. And the reason we do that is because percent is really just the most famous common denominator, 100. In fact, you can think of that percent symbol like representing the fraction over 100, because 39%, or 39 over 100, is 0.39 in decimal. You can think of a percent sign as dividing by 100, which is a little crazy. I don't want to confuse people, but that's kind of the idea here, because 1 is equal to 100%. It's a pretty important little phrase to remember. It'll help you convert between decimals and percent, because while 1 appears way larger, they are in fact the same size. So basically 100% looks 100 times larger than 1, but they have the same value. So if 1 is 100, well then 2 is 200%. And if 3 is 300%, well then 50 is 500% or 5,000%. Notice the percent always looks 100 times larger. And I use the word looks because they're the same size. It's not actually bigger. It just looks 100 times larger. So when you convert a decimal to a percent, the percent should look exactly 100 times larger. What about if we have a smaller than 100%, say 50%? Well, that converts to 0.5 as a decimal. 20%, 0.2 is a decimal. 1%, 0.01 is a decimal. 0.1%, 0.001 as a decimal. Remember, the decimal is going to read as 1/100th of the size, but they equal the same value. It just looks different because of that percent at the end. The percent essentially says, psst, I multiplied this number by 100. Really, seriously, that's all it really does. Okay? So if a percent is always going to be 100 times larger than a decimal, well, if I want to convert this decimal, 0.83, into a percent, I just make it 100 times larger. That gives me 83, and I add a percent to the end, 83%. 0.04 is a decimal. Multiply that by 100, and I get 0.04%. Make sure I add that percent symbol. That shows everybody that I did the conversion. Even works with larger numbers, 24.87. Multiply that by 100 to convert it into a percent. That gives us 2,487%. Okay? Also works with really small decimals. Same idea here. Multiply by 100, convert 0.0087 as a decimal into 0.87%. Now, you may have picked up on something here. Each of these numbers, when I multiply it by 100, all it really ever ends up doing is just moving the decimal point. So, really what I'm saying here is if you want to convert a decimal into a percent, all you have to do is move the decimal point 2 places to the right and add a percent. Turns it into a percent. Let's try another one. 0.011. Okay, I'm going to move the decimal twice and add a percent sign. Just that simple. Now I've got a percent. 8.75. Move the decimal point twice to the right. Add a percent. 875%. Even if I have a number that's sort of strange like this, 25 point nothing, we have just a whole number, I can use the same technique. Move the decimal 2 places to the right and add the percent sign. But you notice I have 2 empty spaces. I'm going to have to fill those up with 0. Those are our placeholders for decimals. If we have a space and we know it has to be there, a 0 goes in there. Add a percent sign, and we've got 2,500%. And actually, when you guys do this on paper, I usually recommend my kids do it like this and draw little bumps when they move the decimal. Okay, you draw the bumps, make a new decimal, erase the original decimal, and add a percent. Remember, move the decimal 2 places to the right, add a percent. The reason we do the little bumps is we can see what we need to fill in with zeros once we've moved the decimal. So I move it 2 places, make a new decimal, remove the old decimal, and fill up any empty spaces with zeros. Add the percent sign, and I've just converted 20 into 2,000%. So what do we have to remember there? To convert a decimal to a percent, we just have to move the dot 2 places to the right and add the percent sign. Now what about the other direction? What about converting a percent into a decimal? Well, let's look at what we did before. So if I could convert a decimal into a percent by moving the decimal point 2 places to the right and adding a percent sign, do you think I could convert into a decimal by doing the opposite? Moving the decimal 2 places to the left and removing the percent sign? Yeah, that's actually how you do it. Just as easy, but the other direction. So if I have a number like 29% here and I want to convert that to a decimal, I'll take 29, I'll move the decimal 2 points to the left, and remove the percent sign. Now I've got myself a decimal. What about this percentage? 6.6%. Let's move the decimal 2 places to the left. We've got an empty space there. We're going to have to fill that with a 0. And remove the percentage sign, and now we've got ourselves a decimal. 0.066. And remember, if you're doing this on paper, use the bump method. So we've got 43% there. We'll move the decimal, in this case, to the left 2 places, make a new decimal, remove the old decimal, and get rid of the percentage sign. So 43% turns into 0.43 as a decimal. What about 7%? How do we convert that into a decimal? Same way. Move the decimal point 2 places to the left, make a new decimal point, remove the old one, and go ahead and get rid of the percentage sign. Fill in the missing space with a 0, and you've got 0.07 as your decimal. Okay, so how do we convert a percentage into a decimal? We move the dot 2 places to the left, and we remove the percent sign. Wow, okay, we've gotten a lot of this chart filled out. Let's see if we can fill in any more spaces. Well, actually, these 3 are already done for us, because to convert from a percent to a percent is doing nothing. Same thing for decimal to decimal, or fraction to fraction. So those are actually done already. So that just leaves us with 2 more, fraction to percent and percent to fraction. Well, actually, you guys already know how to do these, because we've already seen how to convert a percent into a decimal, and we've already seen how to convert a decimal into a fraction. So if you're asking how would I get from percent to fraction, all I'd have to do is go from percent to decimal and decimal to fraction. It just takes 2 steps. And actually, if you remember, percent to decimal is not even really a step. All you're doing is moving the decimal point. So let's take a look at this in action. If I'm going to convert this 5/20 into a percent, first thing I'll need to do is convert the fraction into a decimal. I'll do that by dividing. You can do this long division or by using a calculator. That gives us 0.25. And then we convert that decimal into a percent by moving the decimal place 2 positions to the right and adding the percent sign. Works the other way in reverse as well. So if I have a percent, like 17%, first I need to convert that into a decimal by moving the decimal point 2 places to the left and removing the percent sign. Then I'm going to convert this decimal into a fraction by using our technique of placing a 1 beneath the decimal point, placing a 0 beneath the other digits, making that into a fraction, and removing the decimal point. So I've converted 17% into 17/100. And of course that makes sense, right? 17% per 100? Yeah, it's just that easy. Okay, let's fill in those places. To convert a fraction to a percent, first I divide to get the decimal, and then I convert the decimal to a percent. To get from a percent to a fraction, first I convert the percent into a decimal, then I convert the decimal into a fraction. Just that easy, guys. All right. Well, good luck with that going forward. Hope you guys have a lot of good luck converting numbers and get real comfortable with it, because it should be something that you can almost do in your head. And pretty much by the time you're done practicing, you will be able to. All right, guys. Have a great day.